If you haven't done so yet, please pause the video and try to answer the question yourself before listening on. Our first step would be to draw a wheel whose radius is 4.1 meters. We can next note a point on the circumference of the wheel, and the question is asking us to figure out how far this point travels as the wheel rotates a certain number of degrees, radians, or revolutions. So perhaps we could stop maybe roughly right here, and that might correspond to one of these given angles. Now, in effect, we are looking for what is known as an arc length. We want to know that length right there. The typical symbol used for arc length is the letter S, and then this angle right here is going to serve as the central angle. And it turns out that it's relatively straightforward to calculate this arc length S because S is going to equal the radius times the angle. The only stipulation when using this formula is that your angle must be in radians. Now, part B of the question gives us the angle in radians already, so that's going to be relatively straightforward. It's part A and C where we have to be a little more careful. Let's begin with part A, which gives us the angle in degrees. So what we have to do is take the 30 degrees and convert it again into radians. And it turns out that 180 degrees corresponds to pi radians. And so if we multiply these two quantities, we end up with 30 pi over 180. But of course, that can be reduced by dividing the numerator and denominator by 30, giving us pi over 6. So this would be the correct angle that we're going to be plugging into the arc length formula. So let's go ahead and do that for part A. So we'll plug in the radius first, which is 4.1 meters, and then the angle that we just figured out in radians, pi over 6. We could then pick up our calculators and simply multiply these two. And when we do that, we get 2.1 meters. So this would be the correct answer to part A. For part B, we're going to use the same formula, the same radius. The question gives us the angle in radians already, so this one's relatively straightforward. We just plug in 30 radians, and then when we multiply this out, we get 123 meters. So this would be the correct answer to part B. Now part C gives us the angle in revolutions, so we're going to come down here and convert the revolutions into radians. Now it turns out that 1 revolution corresponds to 2 pi radians. So the revolutions will cancel, and we're going to end up with 60 pi radians. And now that the angle is in the appropriate form, we can plug it in to the arc length equation. And then when we multiply, we get approximately 773 meters. So this will be the correct answer to part C. So just remember, when using the arc length formula, your angle must be in radians. Thanks for watching. If you liked the video, click the thumbs up icon and subscribe so you can stay tuned for other videos. Remember that you can send in your own question to this email address, and I'll do my best to post an answer to it on YouTube.